Howdy! My name is Chastin, and this is... Wait a second. My project. Now, cells are cool. They are tiny. I could stand here all day of talking about how cool these tiny things are, but the project says to talk about interphase and meiosis as well as the difference between meiosis and mitosis. As well as describing what crossing over is and where it takes place, and I, of course, gotta talk about how meiosis leads to genetic variation, or whatever. Animator, do your thing. Thank you, Animator. Now, this is a cell. They're tiny. You can't even see the good stuff. But if we zoom in, we can see said good stuff. This is a step we like to call interface. Look, stuff's happening. Now, usually we wouldn't be able to see the chromatids, but this is my word, my rules. Anyways, this is mainly what basically happens in the interface. Pretty boring stuff. Before we begin, meiosis has two phases, 1 and 2, which is pretty obvious. We're going to start with number 1 because we are number 1. Next is prophase 1. And pause. This is where I touch up on one of my bullet points. This is where crossing over takes place. What basically happens is while homologous chromosomes are condensing, they are bound together in a process called synthesis, or however you say that, which in turn allows for crossing over. It all comes in a perfect circle. Anyways, some of you brainiacs out there are probably wondering, but Chastin, what is the scientific definition of crossing over? Well, I tell you, according to this dictionary, it is... Crossing over is where a chromosomal segments are exchanged between a pair of homologous chromosomes. Crossing over produces exchange of genetic information. Blah, blah, blah. Let's just say a bunch of chromosomes dropped their stuff and picked up the wrong stuff in a rush. That's basically what happens during prophase 1. Next on the list is metaphase 1. All that really happens is that chromosome intrameres attach to spindle fibers and line up at the tetrads, pairs of chromosomes for those of you who don't know, at the center. Next step is also equally boring. Homologous chromosomes separate to move to the opposite sides and reduce from 2N to N. This is called anaphase, by the way. Anaphase 1 if we're being specific. Next is something much more interesting. Telophase 1. Chromosomes reach opposite cell poles. Then, the nuclear envelope reforms and the cell splits in half, creating haploid cells. Now, we're not done quite yet. Hang on for a bit. Now, all of this happens again in the second phase. The only difference is that chromosomes position in the middle, not in pairs. Crossing over doesn't happen as well. Also, during anaphase 2, sister chromatids are pulled apart, not pairs. The end result are 4 haploid cells, each with a number M of chromosomes. Yay, we're done! All steps are covered. We survived. Now, don't give up on me now, but there's been a mistake made by many. What the heck? What's the difference between meiosis and mitosis? Blah. Yeah, that. Well, the big obvious reason is that meiosis has 2 steps and mitosis has 1. But the one that'll give you more points is meiosis is only related to creation of gametes, eggs and sperm, while mitosis is related to cell division and growth and other stuff. Now, most of this paper was talking about meiosis steps, but I'm pretty sure this next one's a doozy. How does meiosis lead to genetic variation? Now, stick with me here. Meiosis contributes mainly because of crossing over. Chromosomes are actually DNA. For those of you who don't know, when crossings over are happening, parts of DNA are being swapped from each homologous chromosomes involved. And that's why meiosis helps with genetic variation. Another way to show this is with a friend, Putnam squares. Now basically this is how it works. Draw one diagonal line, now draw one line in the middle. Add GG on the top columns and GG on the side columns. The end product should look something like this. There are tons of combinations. You can use different colors, leathers, and sizes. This helps explain how genetic variation works. Think of it as sorting random stuff in different squares.